Hey everybody, Dan Hewitt here at the Johnson Space Center. I'm in the space vehicle mock-up facility over by some of the Orion capsules that we have. Orion, of course, NASA's next generation spacecraft. I'm here with Jeff Fox, the Orion Cockpit lead engineer, and we're standing by as they're doing some Orion Cockpit Egress evaluations with a fully suited crew. First off, Jeff, thanks so much for being here today. Give us a little background. Why are you guys doing this test today?
All right, the current design with the Orion capsule is a set of, think of when you land under the parachutes and a hard landing, you need to attenuate or dampen that load. So in your car, you've got shock absorbers, and in the current design, we have very large struts that attach to the ceiling, if you will, and the mock-up behind us.
Probably very heavy, too.
Heavy, large. We also have several that are in different directions, so in the X, Y, and Z directions, if you will.
Okay.
Attached to that is a large pallet, and then the seats that the crew sits in, there's 4 crew in a kind of a rectangle, are all part of that one system. So the whole system, when it hits the ground, can stroke in a hard landing all at the same time. But there's some challenges, some pros and cons of that kind of system. Obviously, it's heavy. It takes up a lot of volume. So as the years went by, we got a little smarter on the landing loads, and we also had some very big challenges with scrubbing out as much mass of the vehicle as we can. That's always a challenge for a space vehicle. So we came up on another concept where we could just have individual seat frames and have those just provide the option to provide some of that stroke that we call, or that dampening, just in one direction along the spinal axis if we were to need it in a real hard landing. So instead of having all these large pallets and struts, you've got just an individual seat frame for these 4 seats with a little bit of stroke built into each one of those if necessary. That opens the cockpit up, but you still got to convince yourself, hey, you know, the layout's changed. I got to get in here and assess some different aspects of it now, like with the crew, which we're doing behind us right now. Can they get out of the vehicle, you know, easily, quickly? Do they have the right handholds? Are there obstructions?
Can be very important.
Yeah, and think if you're on the pad, you need to get out in a hurry.
Yep.
So have I done anything with this change that's made that harder? And that's the key area. Where also the seats sit in a kind of a 2x2. If I think like that, 2x2. We're looking at relocating one of those seats kind of in an off-axis symmetrical config. So what does that do to us, you know, if we were to do that? And the reason we would do that is because the hatch on one side weighs a lot, and right now we have to put ballast on the other side of the vehicle to offset that. Well, that's wasted weight we don't want to carry. So if we can have a seat in a crew take the place of that, that's a good thing. But again, that egress path getting out of the mock-up may have challenges, and we want to know, are there any? Get feedback from the crew on that. In addition, there's other areas that this affects. For instance, access to stowage, which is underneath the seats in this vehicle.
So it's not as easy as just moving a seat. You got to think of all the other systems you're going to affect.
That's exactly right. Other areas are, you know, just using the potty, for example. You know, we have a system similar like shuttle or station, right? You don't want to mess that up. And that happens to be in a plane that's below the seats, and this seat frame is underneath that. So did we do something that made that harder to work in that volume underneath? We want to know that. So we're doing those kinds of things. So several aspects.
Okay, and like we had mentioned, you're using fully suited crew members today.
That's right. You know, previous to this, we did with a shirt sleeve, you know, non-crew subjects, because we wanted to learn about, you know, any difficulties or things that could make this test faster and more efficient, because crew time is obviously very precious.
Yes.
But getting the crew in the suits adds another element. You got a helmet on, that's clunky, it limits visibility. You've got gloves, you've got big boots, you've got a looser suit with
a lot more
other things
to
hanging
snag
off.
on,
Exactly right. So did that introduce anything? So, you know, that's what we're finding out literally as we're speaking. So we'll look at the data. You know, we'll make some, you know, summary recommendations. You know, we found this and that, and ultimately to inform the program that, you know, yay, nay, are we good with this change? You know, so that's the test in a nutshell.
And I know you're really excited because this is the first time we've really been doing this kind of suited testing in a long time, correct?
Yeah, you know, as you know, we've had, you know, quite a few changes in the program, and you know, Orion has continued on, but it's been over 3 years since we've done any kind of suited crew evaluation. So obviously there's some excitement and buzz. It's the first time, you know, we've doing this in a while, and plus the team's relearning and refreshing itself and putting the all those processes back together. So, you know, it's been a joy to work on it.
Yeah, I'm sure the astronauts are having some fun too.
Oh yeah, absolutely.
All right, well, Jeff, thanks so much, and we're going to check out a lot of great footage from this test and follow along. Again, thanks for giving us a little inside look.